Alright, so we've looked at this same portal frame in another example where we had gravity loads. Now we've gotten rid of those and we're only going to look at a lateral load and see what happens. Now we definitely have sway, and we have to figure out with the moment distribution method how you handle sway. And so the first thing we're actually going to do is try to get a gauge on what we think the responses are going to be, and let's use the portal method to do that. Recall that in the portal method we have to make assumptions about inflection points and about what the distribution of the lateral or the story shear might be to the various columns. And what we'll do here, it's pretty simple because we only have two columns, they are identical, so it makes sense. Let's just assume that the total story shear would be half, and that means of course that that would be 5 kips and 5 kips for that particular set. And then let's go assume that our inflection points for the columns are at mid-height, so that means that's at 7 foot there for each one. And that's going to do a whole lot of things for us, right? Because then we can come along and consider the setup of the situation that there's 10 kips, there's your 24 foot, but now we're at mid-height, so 7 foot. And yeah, we have some axial forces we might be interested in knowing about, but you've got those then story shears, or rather column shears, that are at 5 kips, half of this. So that makes it easy here that at the top of the column we're going to have 35 times 7 or 35 foot kips, and at the bottom of the column, because we're at the mid-height, another 5 kips times 7 feet to get that particular moment. And we'll end up then with the moment diagrams for the columns being nice and symmetric, and they will be then at, let's see, remember 5 times 7, so 35 on either end because of that symmetry that's going on. And of course likewise in the beam we're going to end up also with 35 for that equilibrium of the joint, and we'll have 35 there and 35 at the other end. Right, that's our approximate. Now we could also from this figure out what the axial forces are going to be. We can do this in multiple ways in reality. We could sum moments up at the mid-height here, we could sum moments about say one end. That would be then, we're going to get that axial force would be equal to 10 times 7 or 70 divided by the 24, or 2.9 and change for that axial force. And so of course that would be the shear up here at in the right up here, and so in the beam, and 2.916 times 24 would be a total change of 70, and of course that's what we got to have in the total change over from here to here. So in our approximate method, here's our moment diagram that would go along with our assumption of the mid-height inflection point and also the distribution of the story shear.